Okay, so today we're going to be talking about exponents. We're going to be talking about negative exponents as well as zeros. So for our first example, we're going to look at this. If you look at this right here, x to the seventh times x to the fourth, let's talk about how we would do that right now without having any of the rules, which we're going to be talking about kind of generalizations down here. Without that, I would actually just write x 7 times. So I would have x times x, 1, 2, 3, 4, 5, 6, 7. So that's my first one. And then I would have times, and I have 4 more of those, x to the fourth power. 1, 2, 3, 4. What we end up with is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We can now make that x to the 11th power. Well, if we think about what we could have done right from the beginning here with the 7 and the 4, if our bases are alike and we are multiplying, do you notice that we could take the 7 plus the 4 and we would have 11 of them? We would have 11. So we're going to talk about that generalization in just a minute. Okay. So the next one's a little bit different. So that was A. Now we're looking at B. We have x to the third, but we have that raised to the third power. Now that's a little bit different. I'm not going to expand this one right here in this example because there's really no point in expanding it. But what I'm going to do is I'm going to write this 3 times. Just like I wrote this right here 7 times, I'm going to write this thing 3 times. So I would have x to the third times x to the third times x to the third. Well, now we see this is really like this example right here. I have 3 x's and 3 more x's and 3 more x's. So I can just add these exponents. And what I get is x to the 9th power, x to the 9th power. Now, that does not mean that I add these. In this example, when I had x to the 7th times x to the 4th, all I did was add my exponents. But here, this is called power to a power. I don't add them. I actually end up multiplying them when they're like that. Okay, when there's power to a power, then I end up multiplying. Again, you can always break it down this way though, and even further and write the 3 x's, the 3 x's, the 3 x's to see that there are 9 total x's. But we're going to be talking about this rule and I'm going to be referring to it as power to a power. Okay. Looking at C, so now we're looking more at kind of like the simplifying end of things. So on C, we have m to the 14th power over m to the 2nd power. Well, if I expand that out, I would have m, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. I know that this is a little bit ridiculous, but I want you guys to see how this rule is going to work for us. And I have 2 m's down below, m times m. Well, what we can do in math when we have this is I can cancel out 2 of the m's on top and bottom because those cancel those out. So I'm left with 12 m's on top. So I'm left with m to the 12th power on top. Well, if I look at that, m over m, so bases are alike, and I'm dividing. What I do with my exponents is I subtract. So I could have done m to the 14 minus 2 right off the bat. That's kind of the opposite of this. In this one, I had bases were alike and I was multiplying, which is obviously the opposite of division. And I was multiplying, so I added the exponents. Well, now when bases are alike and I'm dividing, I subtract the exponents. Since those are opposite of each other, so are what we do with the exponents. Okay, there's a couple more examples down here. I'm actually going to do this one right here, D, just so you can get a feel for it, and then I'm going to pick one of these other ones. I'm actually going to do F. But on this one, when you have x squared, y squared raised to the fourth power, again, I'm going to go ahead. I'm not going to simplify this. I could do x times y, and then do that 4 times if I wanted to. Instead, what I'm going to do is I'm going to write this whole thing 4 times. So we have x squared times y squared, there's 1 time, times x squared times y squared, there's 2 times, times x squared times y squared, there's 3 times, times x squared times y squared. There's my 4th time. First, second, third, 4th time that I've written that. Now what I do is I count. Remember, now I'm just multiplying my x's. So it's almost like a combining like terms thing. But how many x's do I have? Well, here I have 2 of them. Here I have 2 more. Here I have 2 more. Here I have 2 more. I have x to the 2, 4, 6, 8 power. X to the 8 power. How many y's do I have? 2, 4, 6, 8. I have y to the 8th power as well. If you remember our rule back from this one right here, when bases, like I have this right here, and I have a power to a power, I can actually just multiply. I can multiply. So that would have given me 2 times 4 is 8. Y to the 2 times 4 is 8 power. Okay, I'm going to do F just so you see one more of these examples. Then I'll go down and talk about the generalization. But for F, we have 2x to the 12th power, and then we have an 8 on the bottom and an x to the 2nd power. Okay, I'm first going to reduce my numbers. I know that a 2 can go into both of these numbers, so I'm going to do that. 2 divided by 2 is just a 1, so I'm left with a 1 on top. And 2 goes into 8 4 times, so I'm left with a 4 on bottom. A 1 and a 4. Well, now when I have bases are alike and I'm dividing, remember, I can subtract these. I have 12 x's on top and 2 of them on bottom. 2 of them are going to cancel out with these. I end up with 1 over 4 x to the 12 minus 2 power. So my final answer is 1 x to the 10th over 4. I'll remind you, you don't need to have the 1. It could just be x to the 10th over 4 because the 1 times anything is just going to be itself. So you can go ahead and drop that 1 if you'd like, but that's going to be the answer for F. Okay, the last thing we're going to do today is I'm actually going to generalize these for you. So in the generalization, we have x to the m power times x to the n power. When bases are alike and you are multiplying, you add your exponents. So it's going to be x to the m plus n power. So that's your generalization. Sorry, you can't see that. That's your generalization for this rule. Your second rule that we looked at, we had division. So here you were multiplying. So now we're going to have x to the m power divided by x to the n power. When bases are alike and you multiply, you add them. When bases are alike and you're dividing, you subtract them. So it's going to be x to the m minus n. And our last rule that we're going to look at is a power to a power rule. When we have x to the m power, but we have that raised to the n power, power to a power, you multiply. So we have x to the m times n. Those are the 3 rules that we'll be exploring today. Okay, the last thing I do want to mention is the idea of if you have something like this. So if I have x to the m over x to the m power, well, I'll use my rule really quick. That means I get x to the m minus m, anything that you plug in there, 3 minus 3, 4 minus 4. We're going to get x to the 0 power there, x to the 0 power. Okay, I'm going to tell you that anything to the 0 power, anything when you raise it to the 0 power is just 1. Okay, anything to the 0 power is going to just be 1. So let me go ahead and show that on the calculator just so you can see. So I have, let's do 8. 8, and to do a raise by, I have to flip my phone like that, 8, but I can do x to the y power. So I'm going to do that, and then I'm going to put 0 power, and you're going to see we get 1. I could do 3,052 raised to the, and if I do 0 power, I'm going to get 1. Okay. There's 0 of them. There's 0 of them, which is going to be 1. Okay, so now go ahead and look at your practice. You guys are going to be practicing different rules with exponents, and these are the 3 rules that you'll actually be focusing on. Those are the 3 rules that you'll be focusing on for your practice. Good luck.